Mounting an MCP server inside FastAPI seems straightforward, until your tools silently fail to initialize at runtime. We'll see exactly why passing the lifespan context is critical when embedding MCP functionality, and how one missing parameter can break your entire AI integration. The correct pattern ensures your session manager starts up properly, while the broken version demonstrates what happens when this key detail is overlooked.
Hash correct lifespan passed. MCP app equals MCP. HTTP app path equals /MCP. App equals FastAPI. Lifespan equals MCP app. Lifespan. App mount /MCP. MCP app. Hashing correct missing lifespan. App equals FastAPI. App mount /MCP. MCP. HTTP app. Hash session manager won't initialize.
This demonstrates the lifespan management pattern in ASGI applications, where shared resources and initialization logic are coordinated through a context manager. The pattern ensures proper startup and teardown sequences when integrating multiple frameworks or services, particularly when mounting one application inside another. What makes this distinctive is its ability to maintain clean separation of concerns while guaranteeing that all components initialize in the correct order. The approach works by propagating the lifespan context from the mounted application, FastMCP, to the host application, FastAPI. When the host starts, it triggers the nested lifespan contexts in sequence, allowing the MCP server to initialize its session manager and other resources before the main application begins handling requests. This creates a parent-child relationship where the host application controls the overall lifecycle while delegating specific initialization tasks to mounted components. This pattern matters because it solves the common problem of resource initialization in composite applications. Without proper lifespan management, mounted services might fail silently or behave unpredictably due to missing dependencies. The approach is particularly valuable when integrating AI tooling frameworks with web servers, where session management and connection pooling must be established before handling requests. The trade-off is slightly more complex setup, but the result is more reliable and maintainable composite applications. Let's break it down line by line.
Hash correct lifespan passed. MCP app equals MCP. HTTP app path equals /MCP.
This initializes the MCP HTTP application with its designated path. The MCP HTTP app call creates a lifespan-managed FastAPI instance, which is required for proper session initialization and resource cleanup. Without this, shared resources like the session manager won't start correctly.
App equals FastAPI. Lifespan equals MCP app. Lifespan.
This injects the lifespan manager from the mounted MCP app into FastAPI's startup shutdown lifecycle. The lifespan function runs once at startup, not per request, which is critical for initializing shared resources like session managers. Without this, the MCP app's initialization would be skipped, breaking session handling.
App mount /MCP. MCP app
mounts the MCP subapplication at the /MCP path. This integrates the session manager's lifespan with FastAPI's startup sequence, ensuring shared resources initialize exactly once at server launch rather than per request, critical for stateful components like connection pools or background tasks.
Hashing correct missing lifespan. App equals FastAPI.
This instantiates FastAPI without a lifespan handler, breaking the session manager initialization. The lifespan context is required for startup shutdown hooks, like database connections or background tasks. Without it, shared resources won't initialize properly.
App mount app/MCP, MCP, HTTP app. Hash session manager won't initialize.
This mounts the MCP subapplication, but creates a new instance without sharing the lifespan manager. The session manager fails to initialize because lifespan events aren't propagated, breaking shared state management between FastAPI and MCP. Always pass the lifespan parameter to maintain proper lifecycle handling. Lifespan integration pattern. The correct mounting of FastMCP servers in FastAPI requires explicit lifespan propagation, where the MCP server's session manager becomes part of your application's initialization context. Omitting the lifespan parameter silently breaks session management, leaving your MCP tools functional, but without proper resource cleanup or initialization sequencing. Always pass the lifespan context when mounting MCP servers to maintain the full lifecycle contract between your application and the MCP framework.
The server that forgets its lifespan remembers every session forever.